The role of thermal energy storage technologies in the energy transition in Europe and in the world is very important and crucial because it can offer a wide range of opportunities and solutions for the energy transition. For example, it can accelerate the increase of the use of renewable energy supply, can also facilitate the recovery of surplus heat, and it also can be used as a cheap way of storing electricity as thermal energy. And afterwards, the stored thermal energy can be used again to support the power grid in a very robust way. Also, the other possibility or support that the thermal energy storage technologies can bring to the grid is that it can support the grid stability, balancing the peaks of electricity and also the heat loads. So that's a great advantage that thermal energy storage offers to the grid. Some of the challenge of this technology can be divided into technical and non-technical challenge. If we focus on the technical challenge, it's the investment cost of the technologies. They are still quite expensive if we want to compete with conventional thermal systems for supplying, for example, steam. We need to focus on reducing investment costs of different components of the systems. Also, the scalability is a huge challenge because the systems we develop, they are developed for the application. So if we are not able to standardize in the production of these components, it's going to be challenging to reduce the cost. So we need to focus on acquiring the data from the potential users. And once we acquire the data, we are going to be able to maybe standardize the production of the components and hence so reduce the cost, investment costs. Then, if we focus on the non-technical barriers or challenge, this actually applies for all the thermal energy storage technologies, and it's actually the lack of awareness among the users and also among the authorities and policymakers, because they need to recognize the benefits of these technologies, the wide range of benefits of these technologies, in order to also create more regulations that allow the integration of these technologies into the market. Once they are convinced about the benefits, then we can go forward with these technologies. Well, there are different types of thermal energy technologies and systems. They are basically based on the storage method they use. We have the sensible storage systems. They are the most advanced technology so far. They are close to the market, let's say. They are based on storing energy through an increase of temperature. So, as the name says, they store sensible heat in the form of thermal energy storage. And then we have the latent heat storage and the thermochemicals. And these are the youngest one, let's say. There is a lot of different heat exchangers that are developed using latent heat or phase change material as a storage medium that are already included in the heat exchanger. And then the thermochemical systems that work through a reversible chemical reaction at different temperature levels. Since we need to increase the share of renewable energy supply, thermal energy storage are going to support this transition. And we also have seen with the pandemic and with the war that the prices of energy are very volatile. And what thermal energy storage can do there, they can help us to stabilize the systems and also the users. The users want to have a constant, for example, price and supply. And the future is going to require the thermal energy storage because they provide flexibility to the availability of renewable sources. So we can store the energy whenever it's available and decouple this from the availability of renewable sources, and then use it in different applications on demand, using the energy in a very smart way. So the future is going to require definitely these thermal energy components if we want to use the energy wisely. I can quickly identify some tasks for the research centers. On the one hand, it's the continuous innovation in the development of new energy systems or energy technologies. Another very important task that the research center can play in this future system is optimize existing technologies. So we can use the energy in a more efficient way, and that's going to have an effect, of course, in the investment costs of the technologies. On the other hand, I think it's very important that the research centers accompany and also advise the regulators and the governmental institutions so they can translate this information that we have from the scientific point of view into regulations to push the deployment of the technologies and to bring them ultimately to the market. And a third very important activity of the research centers should be to train young researchers and also educate the society, so the society is aware of the importance of the technologies that we develop in the research centers.